So the file that we generated last week is what you are going to use for this aspect. So today we are completing the model building. Yes. So this stage is the last stage of building the model that we are working with. So the first thing is, we know for us to be able to work with that file, right? We have to import pandas, right? So let's run that. So import pandas, right? So now I don't this okay. Let me just put this. This a software called a package called Streamlight. Yeah, Streamlight is a package that will help you to run a local web. Just like when you connect to the internet, right? You run your internet or your browser, right? Yes, you can use Streamlight to do similar thing locally on your laptop without internet, right? Just when you are developing a website. So it is this Streamlight that you can use to test your website before you put it on the general web. So it's not supposed to come in here. But let me just keep it here. So, and to do that, just to install Streamlight, pip install Streamlight, right? And once you do that, you import. We don't need it for this aspect anyway, but let me just explain that. So once that is done, the next thing is for us to import our data set. So our data set now we are importing, don't forget this is the file we generated last week, mtb underscore ocs underscore activity. If you remember that. So if you have run your script, there I'm sure you should have this script, right? So this is the script we generated last time, and that is the script that we're continuing with. So don't forget, always have your directory correctly. This is my own directory. This is where I have it. I have it in the desktop lib23. So make sure you get that, and it's case sensitive so that you are not getting any error message. So the data set is this. So if you look at it, this is what we add. So we have the padded descriptors, right? If you remember, right? We have 882 column. So the padded descriptor contains 881, and the last one, which is the label, is the PIC50. So these are the features, right? Or the characteristics of each drug, and this is the label, the predicted IC50. So once that is done, the next thing we do now is, because we want to plot a graph, right? To build a model. So we have to signify which one is our x going to be on our x axis and which one is going to be on our y axis, right? So the x axis are going to be the features, the characteristics. This 800, the 800 and we have 882 columns. 1, 2, 3. We can't hit 882. And like I said, this is our feature that is going to be this IC50 is our label. That's the y-axis, and all the remaining 881 will be our x-axis. So we want to save all our x-axis into x. So that means x equals to data set dot drop. Drop means from this data set, all these 881 column, 882 column, drop the last column, the PIC50 column, and save the remaining 881. So we are all our x, don't forget our x-axis is going to be from this up to this, not this. This is not included. This column up to this column. This column is this PIC50 is not included. So from here, that is going to be our x-axis. So that's why we said x equal to data set dot drop is the function. So what that means is save everything in the data set, but except PIC50. Drop PIC50, right? That is at the extreme end. This is it. And save every other thing as x. So if you run this now and you look for x, right? You will discover that if you go, it's no longer 882, it's now 881 columns, right? So if you go down, can you see we've dropped the PIC50 compared to this one? This one is when we have the PIC50. Now we've dropped the PIC50. So that's what that means. This is our x-axis. Now, our y-axis now is going to be our PIC50. PIC50. So if that is the case, you will now use the function. If you remember when we talked about the ilog and the log function, right? So our Y is going to be dataset.ilog. Nothing is going to be in the row. Now the column -1. And if you remember, -1 means it will start from this end. If you put 1, that means it's going to be from this end. But if you put -1, it's to start from the extreme end. If you remember that, I remember I personally took that class. So that's what, can you see? That's also, we are only saving only the PIC50, the -1, as our Y. So if we run this now, then our Y is good. Our Y equals to what? Our Y is the PIC50, right? So that's one. Now the next thing is to remove low variance features. In case there is any low variance features, it is always good to remove them, right? And you can't say whether there is or no until you run the script. So this is the script. So we have circuit length. I think Dr. Scott took the class for some packages and modules in Python. And I think he mentioned scikit-learn, SciPy, and the rest. So this is one of them. To remove low variance, you import from scikit.feature_selection, you import variance threshold, right? And you use this script to define remove variance, low variance. And if that is so, we remove that from our x-axis. Remove low variance from x-axis. And when we run that, so when you see this start, that means it's still running. So let's wait for it to finish running. Yeah. So can you see? That means that we don't, because we still have the same, that's 1,238 rows. And we now have, can you see, we've removed low variance. If you look at this, initially, how many do we have here? We have 1,238 rows, and we have 880 columns. Now that we have removed those ones with low variance, right? Can you see that the column has reduced from 282 down to 252 columns? So that means the remaining over 500 plus columns are low variance. That's why I will remove them out of that. So once we remove that, then we can save this X that we remove. We want to X dot to X, I mean save X to or CSV file, and we save that right now. So once that is done, this descriptor X_list in the app, what we are going to do is every new compound we are predicting in our model, we still have to predict their padded descriptor. Yes, we have to. So we are going to use this also to build our website or our model. Now, once everything is done, the next thing is now for us to build model. Yes. And in machine learning, there are different packages. Please let me just, there are different, in machine learning, there are different type of model. There are different type of algorithm that is available to build model. Yes. They have different, I think let me just drop this assignment. Please, everybody should go and read about different machine learning model for different specific data. Let me say that again. Read about different machine learning model for different data. Yes. So there are a lot of there are different type of model. Let me see if I can show you this particular. Let me show you one example of. Let me show you. Can you see? So these are example of model that we have in machine learning: decision tree regressor, extra tree regressor, or regression process. All of these are model. These are the model that will help you to study. These are the model that will study your data and say, okay, well, based on this data, this is the trend. So the models are the one that will look at your data and say, okay, from what you have seen, this is the trend. When you have this and this and this, this is what you are. This is your class. When you have this and this and this, that is your class. So this is an assignment I'm giving to everybody. Read about different models in machine learning and the data, the type of data they are being used for. Yeah. So in this model building, we have random forest regression model, right? We have decision tree regression model, right? So I'm going to use these two, and to test the accuracy of your model, right? You have to calculate what is called R-square value. R-square value ranges from 0 to 1, right? The higher the value, the more accurate your model is. So when you have a model that, so let's say in this case now, in this model that we're building, we can decide, okay, which model are we going to use? So in most cases, people try different model. You can try like 5-10 models and see which of them is going to give you a high R-square value. Do you get my point now? So, like, let me use like this example, like this one I just showed now. This is a different study, right? They try to run different model. Can you see all this model and see, okay, out of this model, which one is going to give us a high value? And if you look at this decision tree regressor give us the highest of 0.76 down. So in this kind of project, like, okay, instead of using last that give us a very low value, like, okay, or maybe like instead of using position regressor that give 1.1 R square, that give a 0.17 R square, then that means they want a decision tree regressor that gives 0.76 will be the best model for this study. Yeah. So let's go back to the one we are building. So in this case, I will just use random forest regression model and decision tree regression model. So what we have been doing in the past is we are trying to develop features, molecular descriptors, and defining certain parameters for our data. Now that we have done that now, it is now left for us to give that information to a model. It is the model that we now study, that data and say, okay, from data you are giving to me, any compound that has this type of descriptor, this is going to be the IC50. So this model will correlate the features, the different all this 1010, right? The model will be the one to now say what is the correlation between all these features, right? All these 100, what is their correlation with the PIC50? Yeah, that it is the model. So you can use different set of model to see which one is going to give you a good R-square value, because the R-square value will be an interpreter of the accuracy of the model, right? And like I said earlier, the higher the model, the higher the R-square value. Please, Grace, kindly mute, please. Kindly mute, please. Yeah. So the model, the higher the R-square value, the accurate or the better your model is. So now, don't forget we have defined our X, right? And we've defined our Y, isn't it? So in doing that, we have to, from circuit length assemble, we have to import this. So majority of the models, or let me say the models are, majority of models are in scikit-learn.assembly, in a scikit-learn package. So you have to import whatever model you want to use, right, from that scikit-learn. So that's what you do. So from scikit-learn metric, we import mean underscore squared underscore error, comma, and R-square on R2 underscore, right? So because we will be using this, so we have to import this from this scikit-learn package. Now, what we're now trying to do now is we are now defining our model. So model equals to, in this case, we are using random forest regressor. So random forest regressor in bracket n underscore estimator. These are some of the functions that comes with this. Equals to 500. Our random underscore equals to 42. These are the description that comes with any model that you are building. So model dot fit, you have to put your X and Y, because we are trying to build a model from our X and our Y already defined, right? So model dot fit. So this, what we are trying to say is, with what you have defined model to be, now fit X and Y. So R square is now equals to model dot score X and Y. So give us a score from what the model has been trained to do. What is the score? What is the correlation score that you can derive from and Y values. So if we run that now, that's okay. Hey, sorry, because I forgot to run to import. Yeah, because I didn't import. Yeah. So let's see, it's going to give us, when you see this dot or you see this asterisk, it means your Python kernel is still running. So let's wait for that. Yes. Can you see? So saying that our R square is 0.81. Right. That means this model is 81% accurate. 81% accurate. Adibel is giving us something like 40, 42. We might be thinking maybe our data is wrong, or maybe we should try another model. Do you get the concept now? So that's it. So this random forest regression is telling us that our R square value is 0.81, which is not bad, right? Which is a high score. So let me also use let's use another model also. Let's compare this R square. Let's use decision tree regression model. So the same way from scikit-tree, import decision tree regressor. All these models, they are algorithm that has been developed. So you just need to import them from the scikit-learn. So in the same manner with this model, we define model to be decision tree regressor is what you are using. Maximum depth, like I said earlier, so this one is using n estimator, but this one is maximum underscore depth equals to 500 random underscore state 42. Now model dot fit x and y as usual. Then R square. I purposely use R square b because if I use R square 2 again, it will wipe off this value. So R square 2 b equals to model dot score x and y. And let's run that and let's see the predicted RC50 R square. So the predicted R square for this one is what? Is 0.84. Can you see? This one is 0.81. This is 0.84. So which means either the decision tree regressor model or the random forest regression model we are using, at least we have a very good accuracy. So now we have built our model, right? So the question is, how do we translate this model that we have built to something that we can use to develop a website, to develop a server? Yes, not a website, a server, not a website, sorry, a server, right? So that people can come and input their structure and they can get prediction. So to do that, there is a software that is called Pico. Yeah. No, sorry, before we even go there, so now we now have ask value for our decision tree and and the decision tree and random forest. Now the next thing is to build our model prediction. Yes, model prediction needs to be built. And most of the time when you are building model, now let me say this: when you are testing a model, right, in machine learning, out of this you have to divide your data into two. We have what is called a trained data and a test data, right? Trained data is you use the trained data to train the machine, right? And use the test data to test the accuracy of your work. And that is exactly what this is done. So I can assure you, out of this 1,238 rows that we have here, this model use 80%. It's usually 80%, 80 to 20%, 80% of this data, right? Which is about 900 or so, to train the model. And the remaining 20% is used to test the model. And that is how we came about the R square value. So it's like when you are doing when you are doing an experiment in the lab, you will definitely have a positive control. So when you train the machine with already known data, right, it is always good to also test the machine with a already known data. So we use 80% of the known data of this 1,238 to train the model, right? And we now use the remaining 20% to test the accuracy of what you have used the system to train. And the accuracy is saying that from the 80% that you have been trained and you are not testing 20%, I can say the accuracy of your model is 81% based on random forest, and the decision tree says is 84% accurate. So that is the meaning of R square that we spoke about. Now, let's just do some kind of visualization. So let's do a kind of a model prediction. So now we already have our y underscore predict. That's a new variable. So model dot predict x. So predict x, right? Now let's look at the performance. So mean square error, right? We have our standard error for y predict that we already have there, and we also estimate the R square for that. So we are trying to follow up to predict, right? So we are trying to test this model performance. That's what we are trying to do. And if you look at our R square again, it's still 0.85. That means it's using the decision tree model, right? Now, and the standard square error is 0.36, which is which is low, right? So now let's now do a kind of data visualization of the experimental versus the predicted QSAR for train data. Don't forget I said we have the train data and we have the test data. So to do that, we have to import the matplotlib.pyplot as PLT and numpy, right? So we use this script now to test that, and when you run that, it's going to give us a plot. Now, let me now show you what. Now, let's look at this plot very well, please. Now, so what you are trying to do is this is the IC50, PIC50 from 0 to 12. This is the predicted PIC50, right? So if you look at this, you can see to some extent that the higher the PIC, the higher the predicted PIC50, the higher the experimental PIC50. So you can see there's a kind of positive correlation between this and this. You can see our data are almost on the same side. And that is why the machine is giving us a regression line. So let's assume all this, you can see all this data, all the like over 1,000 data PIC50 that we plot. Can you see they are almost on the same line? Majority of them, there's a cluster around this side, right? But I think we add the scattered plot. We have a lot of them here, a lot of them here, everywhere in it. Definitely, we are going to have a low R square value, right? So the more your data correlates, the more higher value of R square value that you are going to have. So we are just trying to use this to test our model, and we can see from this, right, that we have a very positively correlated plot. Now that this is just to test and to visualize our model, right? Now that that has been done, now the next thing is to save our model. This is just we have built the model, right? The next thing is for us to save our model, right? And build it for us to be able to build a server that can be used. And to do that, we use what is called a package called Pickle. So I'm going to send this to you, and I'm going to give you the command, Python command to build Pickle, right? To install a package, right? So once that is done, and do not forget here, we've already defined our model, right? So we are using this decision tree. So what we are now saying is this, that Pickle now dump and give us build from this model. Let's build what a mtb underscore model.pickle, right? So all the model that we built, we are saving it now. So let me import this first. So we are saving it. The model that we've just built, we are saving it as mtb underscore model. Let me run it. So let me go back to where I have where I'm saving my. I think I have it on the yes. Let's look at that. Let's look. Do we have model pickle? Can you see this? So I've saved the model. Yeah, I've saved the model. So the model has been trained. mtb underscore model. That has been trained. Any questions so far before we proceed? Do we have any question from anybody? Question? Okay. No, okay, fine. So now successfully, we've built our model. Yes, we have done that. That means we have used the features from the compound's canonical smile, right? And we have matched that to their respective PIC 50, right? So the next thing is, how do we now build the server, right? How do we build the server to so that we can have a server that everybody can drop their structure and they can build. They can predict the IC50 of their drug, whether it's going to be active or it's not going to be active against tuberculosis. So to do that, I, let me walk us through now. This is the server Python program that's already developed, that already wrote. Now I will walk us through it. Now we have the first thing is to import. This is a Python script. Is to import all the packages, right? Now Streamlight. You have to have Streamlight installed. So Streamlight is installed because a Streamlight that will be used for us to be able to run the server locally on our laptop without connected to the internet. Pandas is the one that will help us to import our files, right? PIL image import. In case you want to put an image, like the one I built, I put leap, right? So in case you want to use any image, and if you look at most of the website that you see or server that you see online, you will always see image attached to them. So they use either this package or another type of package to import their image. Now, subprocess will be used for our descriptor calculation. Yes, and also the OS will also be used to help us in the run of the server. We also have the base and we also have the PICU. So the PICU is the one that will help us to make use of the model, right? So the first thing we have here is the molecular descriptor calculation. What this means is all those molecular descriptions that we calculate for our data. If anybody is dropping a new compound, the server is going to calculate the same thing. It's going to calculate the descriptor for them, and that is why we have this part. So when we bring in a new compound, the server we are building will calculate the predictor. It is after the predictor has been calculated that you now match it, right, to data the information on our model and say, okay, based on this description, this is likely to be the IC50. So that is going to be done. Then we also have the point where we can download file. So for instance, now maybe you put 10 compounds on the server and you run it and it gives you a result. You don't need to be writing the result with hand, right? You can download. Yes, we already put this script will help us to this particular script will help us to be able to download the result from the server. You don't have to be writing it down. It will download it for you as a text file, right? So this is the model building part, right? The model building part. So we have our model is the mtb_model.pl, right? If you remember, this is our model, right? So what we are saying there is load model for input data. You load your input data, it will predict for you, right? The IC50, the molecular name, and everything. Now, logo now, if you want to input logo, right? Image is equals to image.open. So in this case, I've saved the logo as logo.png. So if you save if you save your logo as maybe MTB logo, you have to put MTB logo. If it is in png.png, if it is in jpeg.jpeg, right? So the next thing is for us to have a markdown. Yes, there may be some word you want to write. So in this case, I put activity prediction app for MTB. This app allows you to keep activities towards inhibiting the MTB. MTB is one of the leading cause of death, so you can just put in the word result interpretation. So to interpret the result. Now, for us to be able to interpret the result, we have to go back. What is the IC50 of the PIC50 of the predicted, of the active and the inactive compound? Okay. So for us to be able to give that, you have to come back. Let me open this as PDF. Yes. Sorry. Okay. If you look at this now, that means this is the active compound, right? Inactive. So that means based on this, the P50 of the active compound starts from 4. So any compound that has a P50 4 upward is active against MTB. Anyone that is below 4 is inactive. So in that case, let's go back. So we have to define that. So we said yes. We said P50 greater than 4 is active. P50 less than 4 is inactive. Can you see? So anybody that is using this server, they already have this information. When your P50 is greater than 4, your compound is likely to be active against MTB. When your compound is less than 4, it is going to be inactive, right? So, and we also try to put credit are built in Python plus Streamlight at Center for Biomedical and Humanity, etc. by Dr. Dowu and by Dr. Dowu, Dr. Smith, Dr. Scott, sorry, Dr. Scott, and all LEAP 2023 students, right? So then we also give credit to the padded descriptor that we use the descriptor, right? So then the sidebar, so the sidebar is where it will permit you to upload your files. So you can upload your files as test, right? Then I also put, in case you want to test, I put an example. I know we've come across things like that on website before, where you see them say, okay, before you run your own, maybe you should run this example we have. So I already put some canonical smile in example folder on this. Yeah. So before you put on, you can decide to run the samples that I have. Let me look at this part. Is this part correct? Desktop leave, desktop leave, desktop leave, desktop. No, it's not correct. Desktop leave 2023. Drug D. Drug D. So I have to go and copy that. So you provide the part with the example, right? And this is the sidebar that we use, and this part will help us to be able to do the description. And this part will calculate the molecular descriptor, because for every new compound that you are doing on the server, right, your server will calculate the molecular descriptor, and from there it will be able to merge it to the information that you already used to train your model. Do you get that now? So once this is done, let me save this because I've made some changes. Yeah, saved. So the next thing now is this. So anything we have been doing for the past 3 weeks, right? It's on this folder, right? Everything. So now, because we need logo, I create this logo. Let me just show you this logo. I will see. By the time we are going to change it to make it more fancy, right? So, oh, sorry, this is charge. 1 second. So every document should be in here. All the documents should be in here. The molecule.si, the descriptor list list. So everything must be in the same folder, right? Can you see? This is the app that this one is here. So everything must be in the same folder. Now, so once you have done that, the next thing is for us to, and you have installed Streamlight. The next thing is for us to run our server, right? Once we make sure everything is there, we have, this is the application, right? This is the logo, this is the, so everything that you input here, that is here, everything must be in the same folder. So I think an example folder, let me go and copy the example folder from somewhere so that we can, just give me 1 second. I think I said this. I think I did the example for that somewhere. Okay, let me copy that. Yeah. So if you look at this example folder, I already put some canonical smile that people can use to, as you know, as a trial, right? So that's fine. So once that is done, the next thing is for us to run our what? And if you look at this, if you look at this app is a Python folder, not a Jupyter notebook, it's Python. So what we need to do now is to go to our Anaconda, right? Let's open a terminal, right? A terminal. So when you open a terminal, you have to go to from the terminal, I have to go to this folder, right? To this folder, and I think I don't know to CD desktop. Yeah, for many of I don't know if I didn't take this session sleep student Linux command, but the last student remember we taught Linux command. So to move from desktop, so after desktop, so you can let me just make it simple. After desktop, we have lib 23. So from desktop, let's move to lib 23. So CD again, lib 23, right? So after lib 23, we are going to this folder. We have drug D, right? So CD again, CD drug D. So make sure on the Python command, you are in the folder where you have all your stuff, right? Make sure you are there. Now, once you are there, the next thing and everything is in that folder. The next thing is to run Streamlight. Streamlight run. This is the Python folder app.py, right? Run app.py and press enter. It must, if everything is fine, it must connect you to your server, directly to your server, directly to your server. So this is the logo that we put, this is the image. MTB is because activity prediction server, but activity prediction app, MTB. This app, remember we wrote that allows you to predict the activity towards the emission of MTB or a bit towards emitting MTB. MTB is one of the leading causes of death in the world. Result interpretation, KIC50 greater than 4 equals to active and K50 less than 4 equals to inactive. Credit, app built in Python Streamlight at the Center for Biomedical Minority Health Research by Dr. Dovu, Dr. Scott, and all LEAP 2023 students. Right, that's it. So now, before you can decide, before you do that, let's use the sorry, let's use oh sorry, why is it not okay? Let me use this example. Let me go to the folder. Okay, no such file as descriptor underscore output. Oh, how come? Where do I see it? Descriptor underscore output. Oh, I think sorry, just give me. I think maybe we save it in a different place. Check that out. Okay, I think we save. Okay, sorry, we save it in a different spot, in a different place. So can you solve? So if all your folders are not in the same in the same place, that is this will be facing. Let's run it again. Let's put that. Let's see what happened. Now, so if you can see there is a man dancing here. Let me do that. Let me do that again. Edit. Can you see? A man is dancing here. That means it's running. Now, So these are the things I have in the example folder, right? I don't know why you can't find this example folder. Okay. So all the things, let me go back to example folder. So example folder is this example file. So I have the canonical smile of this compound, random severe, Lipreva, Retanava, Darunava, Lano, Lupinava. I'm trying to test them against MTB, right? So after running it, can you see these are the original data? Can you see this is the canonical smile and these are their names. Do you see that? Then it calculates the molecular predictor description for each of them, right? It gives us a subset of description from previously built model, right? So because I told you it's going to calculate that for all of them. Now it calculated the PIC 50 for these two, but it's not giving us for the remaining two. Why? What happened? Let's go back to our folder and see what happened. Supposed to run for us. It's supposed to run. Yeah, it's not serious. Yeah, it did. But I guess this special of this does not fall into any of it does not fall into any of these because it shows for us that it sees all the structure. So all this does not fall into this. So let's try another example. What suggest a drug for us? Can somebody suggest a drug for us? So from this means since these drugs has 4.1 and this one has 4.0, that means and we already defined in our result interpretation that anything above 4 is what is active. So these two drugs are likely to be active against MTB, right? Whatever what you do, you still have to go, okay, vancomycin, okay. You know, when you are teaching pharmacy students, you start to hear different type of drugs. PopChem, let's go. To get chemicals, might just go to PopChem, right? And let's look for canonical smell of this in PopChem. So canonical smell of vancomycin. This is the canonical smile, very long. Control C. So you can create, let's create a new test. Let's paste it there, right? Let's give it VYC. That's the name. So let me save this. Let me save it in that. Yeah, let me save it in desktop. Oh, sorry. It's VYC. So that one is not saved. Oh, sorry, that's okay. So let's go and predict this now on the server. So let me click on browse file. So I save it on desktop. Let's go to VYC. This VYC. Open VYC. Let's click on predict and let's see what happens. What happened? Why is this giving me? Okay, sorry. Let me go back and check this app. Maybe something is wrong with this app. check now. It's always giving us penicillin. So okay, we have test. Let me go back to your test. Okay. So for test work for us, let's see. Let me should be able to use other thing. Why is it still giving me penicillin? So something is wrong somewhere. Why is it still giving penicillin? Why is this penicillin still appearing every time? Yeah. So let's go to vancomycin. The descriptor, let me show me this file is appearing somewhere. Coming. So I'm trying to see what's wrong with our script. We are getting this word. Okay, it's coming. Just give me 1 second. It's coming. CD desktop. I run back on my phone. One error with is example, or even of one is required for random forest. Random forest. Okay, I think I know where. Let me switch. Let me take this random forest. Sorry, I'm just going to do something. Okay, I just I want to run that. I'm trying to run this model again. Let's see. Is where the problem lies. Yeah. So I think I found the problem. It's not supposed to be. Output. Sorry, just give me 1 second, please. This again. Don't be this. Call me. Let me. Set up. That's for build. Okay. So do you know what you're going to do? Let me work on this. Something is probably wrong somewhere. I will fix it so that by next week when we meet, I will let us know what is actually is wrong so that I won't take our time too much. Do you have any question that is not there? So next week, by the grace of God, I will look at what actually happens there. Something is probably wrong with our script somewhere. So that by the time we meet next week, we are going to fix that. I need to go back and check what is wrong with that. Uploaded data in the site set to start. Just look at this. Something is wrong.
Let me check something. I compare something. What do you have in text? We have yours. We use example again. Oh. So I'm just trying to give it. I'm just trying to figure out what is actually wrong here. Just let me give it a try one more time. Okay. This okay. Let me not change this. Let's try find common. I don't know why it's not working for biochemistry. Okay, let me see. Maybe it has to be in the folder. Let me see one more time. There's something, tell me something is wrong because I don't know why this penicillin is still appearing in our folder. Yeah. So no, at least we understand up to this point. I'm going to fix whatever is wrong with the server so that we know exactly what is the issue. Right. But let me go back. Let's go back to the test. Let's go back to the test. Let's use the test as an example. Yeah. So I'm going to look. So for the test now, we use penicillin and amoxicillin, right? So if you look at this, we have the canonical smile for amoxicillin and the canonical smile for penicillin. Can you see it calculated the what? The molecular descriptor that we mentioned. Just 882 of them. Can you see? It calculated for the two. And don't forget, we said we are going to remove those ones with low variance. So after removing the one with low variance, it from 882, it comes down to 253. And if you look at it, it predicted the IC50 for amoxicillin to be 5.2 and for penicillin to be 5.4, saying these two are likely or possibly, based on the structure, possibly inhibitor of what? Of MTB. So that's how it works. I'm going to fix. I will look at that. I will look at this script again to know what is wrong with why the other one is not working. But at least for this test example, it works. So that's it. Any questions? So this is what we have been building since for the past 3 weeks now. So do we have any question?
Yes, one question, Dr. K.
Okay.
So for the final presentation we are going to make, will it be bioactivity prediction of activity towards MTB or a different microorganism?
Yeah, thank you. So I just give you a demonstration of this. So next week, I will get the list of every student from Temi. Temi, please send me the list of every student that we have to me. So next week, I'm going to group you into 3 groups, right? So some group will focus on SARS-CoV-2, maybe SARS-CoV-2 protease. Another group will focus on another disease, right? So we are going to have 3 groups, right? And each group will focus on different disease. So during our presentation, we will now decide, okay, which of the do you want to, yeah, if they will be happy if we submit all the 3 presentations, to be fine. But if they give us opportunity of 1 or 2, then we all agree to choose 1 or 2 for everybody everybody can still have, we can still have a good presentation. It's the same approach. The only thing is the data is different. Do we get the point?
Yes, I do. Thank you very much.
Yeah. So by next week when we meet, 2 things next week. The first thing, I'm going to rectify whatever is not making the other file to work. But we can see the test file work. I'm going to let you know what I think I will have sorted that before then. Then number 2, I'm going to group you into 3 groups. And that next week, I will give each member will know whichever group they belong to. And I'm going to give you your data set, like which disease or which organism or which protein will you be developing inhibitor or server against. So I use MTB in this case. Some people may just work on HIV protease enzyme or the old HIV and the old HIV organism, or some may work on maybe Ebola or on another type of disease. Yeah. So I'm going to look with the data set and I'm going to give each group what they do, so that between next week and let me give till mid-October, I expect everybody, each group, to submit their server. They should have been done. So, but during the period, if you have any issue, you can contact me or contact Dr. Smith for guidance. Is it fine?
Yeah, that works.
Yes, sir.
Okay. Okay. So if there's no question, so I wish you guys happy weekend. Enjoy your weekend and see you next week, right?
All right. Thank you.
Yes. Thank you, Dr.
I'm going to
Thank you, sir.
I'm going to forward this script to you so that you can start trying it before you get your group and your data set next week.
Okay.
All right.
Thank you, sir.
You're welcome.
I have a quick question.
Okay.
So as far as our capstone